At its most fundamental, in my opinion, painting is really about translating what we see or what we're feeling into shapes of color that we then put down on a canvas. So really the beginning place is to understand what the properties are of this color that we're using, whether it's tube colors or of acrylic or oil or watercolor, whatever it is. Colors have certain properties, and we need to sort of be aware of those so that we can manipulate color in a way that helps us convey that impression of what we see or what we feel. So that's where we're going to start here. And there are four basic properties of color. There's hue, value, chroma, and temperature. All right, so we'll go through those four very briefly in this video. So hue, starting with hue, that's simply the name of the color. And there are lots of color names you probably saw when you bought your tubes of paint. There are all kinds of names for different sorts of reds or blues. And what I like to do is try to distill those down into a limited number of hue ideas or hue choices that we have. It just simplifies the process. If you look at the traditional color wheel, what we have are 6 basic hues. We have the primary colors, which are red, yellow, and blue. So red, yellow, and blue, those are our primary colors. Those are colors that you can't mix other colors to get those colors. That's why they're called primary colors. And then the second level of hues that we'll be dealing with are the secondaries, and those are the colors that you get by mixing the primaries together. So when we mix red and blue together, we get violet. So violet is a secondary color. When we mix red and yellow, which are primaries, we get orange, which is a secondary color. And then when we mix yellow and blue, which are primaries, we get green, which is a secondary color. And many of you probably know this already. So, but what I like to do in painting and in mixing colors, I find it helpful to just take all of those different colors that are out there in terms of tube color names and so forth, and try to fit them into those 6 colors. It just simplifies the process for me. So up here we've got a lot of different colors going on. So if we were naming hues, as we looked up here, we would look at this and we'd say, well, that's a yellow, right? And that's pretty obvious that that's a yellow. What may not be as obvious is this color over here, this glove. That's also, if I had to sort of put it into one of those 6 camps, I would put it into the yellow camp. That's what it's closest to. Surprisingly, even this cup here, it's very, very dark, but it doesn't help us to say, well, that's just a dark color. It's important to assign it a hue as a beginning place to understand the other properties of color. So we have to make some sort of commitment when we're looking at dark colors like this or this down here. Do those colors seem to be, if we had to push them into one of these camps, do they seem to reflect an essential underlying yellow component, red component, blue component? What is it? And that's how we start making sense of mixing that color. It doesn't do us any good to say, oh, that's just a black, or that's just this indeterminate dark. That doesn't get us anywhere. We have to be able to start articulating exactly where it's fitting on the color wheel in order to use it properly, to get what we're seeing or what we're feeling. All right, if we look at like the reds, okay, so this is an obvious red here, right? That fits. This is also, this is a pinker color, but that fits into the red family. This is more of an earth red, but that also fits into the red family, and so on and so forth. This could be orange, but this is also an orange back here. So they're just different properties besides hue that are going to get us those different oranges or blues. All right. So again, hue is simply the name of the color that we're seeing out there as it relates to one of those 3 primaries or secondaries on the color wheel. All right. Value is the light-dark component. So if you think of a grayscale running from pure white to pure black and every gray transition in between those two, all of these hues that we just talked about would fit somewhere on that scale. So if we took like a black and white photo of that color, where would it fit on that light to dark scale? So if we're looking at, if we're looking at, say, this blue here, like on this box, and this blue on this ball, those are different. They fit into the same hue category. We would both put those into blue camp. But this we would say is a darker value. It's closer to the darker end of that value scale. This is a lighter value. Similarly with these reds that we just looked at, this is a darker value than this red. All right, so we have the hue component, which is the name of the color as it relates to the primaries or secondaries, and then each of those colors also have a value component, a light to dark component. So again, obviously, this is a darker value than this. Right. This is a darker value than this. This is a lighter value than this. All right, so it works with colors that are of the same hue type, but also across hue categories as well. All right, so it's value, light, dark. Chroma, and this is one that sometimes causes people a little bit of problem. Chroma is the intensity of the color. So if you think of a color that's been through the wash a number of times, like a shirt, a t-shirt that starts off really brilliant and then starts getting kind of washed out looking or grayer looking or less intense looking, that color when it started would have a higher intensity. We'd say it's higher chroma, and then when it gets more washed out, it's lower chroma. So again, if you go back to this blue here, if I look at this blue and this blue, same hue, darker value up here, lighter value. In terms of chroma, we'd say this is higher chroma, this is lower chroma. So this is more intense. This blue is a little bit more washed out. Similarly with this red, we'd say this is a higher chroma, lower chroma, because this color seems more intense. All right, and so sometimes it's easy when things are really different. When they get a little bit closer, it becomes a little bit more, you have to look a little bit harder and make a judgment. But there's always some kind of hue difference, there's always some kind of value difference, there's always some kind of chroma difference between two particular colors. All right, so chroma is the intensity. Finally, temperature, and again, sometimes this causes students difficulty, but it's temperature, colors are either on the warm end or cooler end. So when we look back at the color wheel, the colors we normally associate with being on the warmer side are red, orange, and yellow. So that's sort of the warm end of the scale. The cooler colors, violet, blue, and green. So of those, which are the warmest, which are the coolest? It kind of depends on your own interpretation of these colors. We have very individual associations with these colors. But generally speaking, I think of blue as being the coolest among the cools, and I think of orange as being the warmest. People might disagree with that, that's fine. But it doesn't really matter. You're judging one color against the other, and that's an important kind of idea to keep in mind with all of these ideas that we just talked about, is that these are all relative terms. So if I look at, say, this value here on this ball, I can't really just look at that ball in isolation and say, well, that's a light value, that's a dark value. It only makes sense if I'm comparing it to something else. So if I compared this ball to this blue here to this blue here, I would say this is a lighter value than that, which we've already said. But if I compared this to this yellow over here, I would say this is a darker value to the yellow, right? So all of these are comparative terms. Same thing with temperature, and same thing with chromatic intensity. I could find something up here, say like this has higher chromatic intensity than this glove back here, but it has lower chromatic intensity compared to, say, this blue over here. So again, it's a comparative idea. One thing I'll just mention again on the color wheel, the reason I have these lines here is this comes in sort of handy when we're mixing, is to realize which of these colors are complements. So orange and blue are complements, green and red, and violet and yellow. And what that means is when you're mixing them purely together, they have they have the quality of sort of canceling each other out and making the color grayer when you mix them together, complements. When you put complements together, when you don't mix them but put them next to one another, they tend to highlight or intensify the property of the other color. So, so if I put a green next to a red, the green makes the red look even redder. If I mix the green into the red, then I get kind of a dirty brownish color, so it sort of cancels the color out. All right. So the 4 properties: color, hue, value, chroma, temperature, and we'll have a homework assignment in which you will simply be trying to make sense of your tube colors in terms of where they fit in terms of these 4 properties of color.